Hello everyone. So in the last video I talked about row reduction and what it means to solve a system of linear equations, and I introduced the idea of row operations which you need in order to row reduce. So as a reminder, there's 4 different things that you can do in order to row reduce or solve a linear system through row reduction. You can multiply as a row by any scalar factor. You can add a row to any other row. You can add the scalar multiple of one row by the scalar multiple of any other row, and you can interchange 2 rows. So the goal is to have every pivot position, any leading non-zero entry of the row, to be 1, and everything above and below it to be 0. So we start from the left. This would be our first pivot position. 1, everything below is 0. Now we're done with this column. We move on to the second pivot position. Everything above and below to be 0. And then we go on. Sometimes you can't really make all of the pivot positions fall into the diagonal, but as close as you can get. So let's start out with this linear system. So the first step is to write the linear system into an augmented matrix form. So you write each component into its corresponding box. So 5 will be here, 6, 7, 8, 9, 10. Now, we know that the goal is for the diagonal components to be 1 and anything above and below the diagonal to be 0. So let's make this 1. In order to do that, we replace row 1 by 5. So remember that you cannot just divide this 5 by 5. You also need to divide all of the components of the row by 5. That's what it means, row operation. You divide or you perform whatever row operations on the entire row. So now we get 1, 6 by 5, 7 by 5. And the second column will remain the same. So our second goal was to have anything below the diagonal to be 0. So in order to make 8 0, we can substitute row 2 by row 2 minus 8 times row 1. So this would be the third row operation, where you can substitute one row with the scalar multiple of the row itself plus any other row. So in this case, row 2 would be 2, and D would be negative 8, right? And J would be 1, I would be 2. So that gives us 1, 6 by 5, 7 by 15, 0, negative 3 by 5, negative 6 by 5. So what we did was we said 8 minus 8, and then we substituted that here. And we went on to the second column, second row, and we said 9 minus 8 times 6 by 5. And then we substituted that here. Since we got the first pivot position, and we also got all the entries below that pivot position to be 0, we need to move on to find the next pivot position. So for the time being, we want nothing to do with this row or this column, and we move to the next one. The next leading non-zero entry, which is negative 3 by 5. So this pivot position needs to be converted to 1. In order to do that, simply replace row 2 by, in order to be 1, the negative needs to go out. So we multiply it by minus again, and then it's 5 by 3 row 2. So we end up getting 0, 1, 2, 1, 6 by 5, 7 by 5. See how we've almost achieved 2 of the goals that we set out to achieve? First, we wanted all of our pivot position to be 1. Pivot positions are the leading non-zero entry for each row. Second, we wanted everything below and above that pivot position to be 0. We've almost achieved that. In order for this component to be 0, we need to perform row 1 substituted by row 1 minus 6 by 5 row 2, which will give us 1, 0, 0, 1, negative 1, 2. We know that the first column is x and the second column is y, and this is the right hand side. So let's convert the augmented matrix. Since we've fulfilled all of these 2 requirements, let's convert the augmented matrix back into the equation form. So we take the first row out. We multiply x by its corresponding coefficient. So we will have 1 times x plus 0 times y is equals to negative 1. And we have 0x plus 1y is equals to 2. Simply, we got the root of the equation, which is x is equals to negative 1 and y is equals to 2. Which means that this linear system of equations intersects at negative 1, 2. So in the third video, I will talk about the different types of solutions that you can get. This was the easiest one, where the left-hand side represents or resembles a reduced row echelon form. Stay tuned. And please don't forget to like and subscribe to Thapa Academy to support more videos. Thank you.